The
story from a practitioner in this
This
industry.
is the end. The end of the assembly line. The end of the showroom floor. The end of the smooth-talking salesman. The hard sell. The soft sell. The oversized inflatable gorillas. And overinflated inventory that absolutely must go. This is the end of the junkyard full of old cars, leaching chemicals into the ground. Born from the concept of cradle-to-cradle manufacturing. Printed in front of you to be the exact car you want. Melted, deconstructed, and rebuilt to be the next car you need. This is where vehicle manufacturing as we know it comes to an end. And where vehicle manufacturing, as it should be, begins.
Thank you. Thank you. If you're going to transform a brand or a product, an old saying is that you can't do things just the same way. It's the definition of insanity. I think it's been well proven in all that has been discussed that's come before me. So as a practitioner in what's going on in this industry, we're finding our way through how to learn these concepts while we're executing. And so going back to the drawing board and doing things differently was critical. I remember the first time sitting down and reading some of these treatises about Industry 4.0 and thinking about how would I conceive of a business in an industry to bring these new thoughts to bear. And it was imperative at the beginning to go back to the drawing board. So we came up with two poles to hang on to: co-creation and micro-manufacturing. So for us to co-create with someone is a brand or a customer of a brand working together with a community. And the community can be broadly defined to include other customers, to include suppliers, idea givers, solvers, all those sorts of things. And it's by definition a curated interaction. There was a time at the beginning of Open Innovation Methods where you could think about just looking for answers and charging off in that direction. But as you can see, it's a complex landscape. And in hardware, there are pitfalls all over the place. Insurance, finance, safety, operations, legacy employment contracts. So curating is one way to cut through the chaff. And so for us, bringing a community together was essential as the first pillar to hang on to in this effort to go back to the drawing board. Here you see behind me some of our community members, real people that you've heard talked about in general in the last 2 days, but these community members are the ones that came up with the ideas that sit behind them. Amazing young inventors. People who led an ad hoc, breathable workforce to come up with the products that sit behind them. This has been a journey along the way. It's like building a jet engine on the wing of a plane that you're currently flying in. It's a huge challenge to manage the unwashed masses and work with them, because you definitely don't own them, and you don't have an employment contract. But from Sang-Ho Kim in the upper left, who led the Guinness Book of World Records, world's first co-created car effort, the Rally Fighter that you see sitting behind him, that just showed up as Letty's car in the Fast and Furious 8, the Fast 8, all the way down to the bottom right, where you see America's best and brightest co-creating on a paradroppable mission transport with 4G LTE, drone launching capability, and whisper quiet mode for 9 hours. All of these things have been co-created. Micromanufacturing, the other part of the two-legged stool, if you will, that we hang on to in this era of going back to the drawing board. For us, it is by definition expeditionary. We're not trying, as John talked about earlier, to hold on to the core. For us, this is about innovation and manufacturing at the edge of the business. And these assets, the capability of being lean and being able to keep the newest technology engaged at the edge, is what a microfactory allows. When we do work for ourselves and when we do work with other customers, what you'll find is that people say, oh, I already have a factory, so all I need to do is use that asset. And it's not so much about the machines that are there, it's about the forward deployed or expeditionary ethic of engaging those machines in a ballet of a digital symphony to be able to get them to move forward at the speed of a community who's co-creating. And that really is, in essence, what a microfactory is about. So here's a picture of our microfactory in Tennessee. It's been carefully orchestrated as a stage to hold on to this co-creation ballet. But the bottom line is, it is at its best capable of reconfiguring all the time. And the pictures that you see here are using digital methods in order to be able to do work for local motors, to be able to design, build, and sell vehicles quickly. So if you were to look at cliff notes of what we do, we would say that those two pillars, co-creation and micromanufacturing, allow us to be able to launch vehicles, in the case of local motors, 5 times faster, with 100 times less capital, because we use more minds. 5 times faster, with 100 times less capital, because we use more minds. That's the broad stroke. Now, there is a trade-off. There's no free lunch. There's always something that's a gotcha. And for us, we're using Deloitte's graph that they've put forward in the book and adding just one small piece to it, which is, what does it mean to be in the lower left corner? It's the purview of an economy of scope. It's where microfactories exist and excel to make money. So if you look at this curve demystified, and it's in your book, the parabolic curve that goes down from the top left to the bottom right is really more about amortizing capital development. And it's the traditional way that Alfred Sloan gave us to say, this is how you make a vehicle. If you can flatten that curve to what you'd say is the additive manufacturing cost curve, where you don't really gain an economy for scale, you have the opportunity to be able to make a production space that exists underneath this chopped off wave, if you will. And to the left of the break-even line, that's where microfactories excel, because you gain an economy through scope. An economy of scale is an economy that is driven by driving costs down in order for you to be able to expose your margin and be larger. An economy of scope is really the reverse. It is allow you to be able to launch products and increase price or willingness to pay in order to be able to increase your margin. An economy of scope versus an economy of scale. So, going back to a drawing board, when you tie co-creation and micromanufacturing together, what you're doing is you're answering consumer desires more quickly, and you're driving willingness to pay up associated with it. Really important piece here, like super huge important piece, as a professor of mine used to do every time there was something to remember for a test, right? So the super huge important piece is they don't have to compete with each other. You can move from the blue box on the left when you have a George Foreman grill that you discover. It's the theory. Karen talked about it a little bit before about FastWorks, which is based in many cases on the principles of Eric Ries's lean startup. If it works, don't fix it. Make it in mass. But if it doesn't work, sure as heck don't pay for what you have to do to scale it up if it's going to fail. It's a pretty simple precept. So this is that curve explained. Why? Maybe something that's just a skosh different than what you've heard for the last 2 days is the why. The why for me is super personal. I felt that there was an obligation to be great in doing this. And it's what's guided me and the team that has joined me who similarly shares this mission-driven obligation to be great. This was my granddad. He owned the Indian Motorcycle Company, a storied motorcycle brand that was around in the 40s and 50s, started in the early, just around the turn of the 20th century. And effectively, what he did was build a great motorcycle brand that failed in 1953. And he learned a lot about what it meant to dump all the money into a new factory and a new product, and he was building 1,000cc bikes that looked beautiful when consumers really wanted a small block motorcycle. Pretty simple. So, when that business failed, he turned around and said, I'm never going to make that mistake again. And he went into the worst industry to make the change, which was the steel industry. And he built the first mini mill. So the mini mill for him was about, how could I do this lower cost? And he looked around and there's all this scrap steel. And one of the things that was coming out at the time in the 50s was, could you use the scrap steel to lower your cost? And then could you compete in areas where people weren't able to compete before? Clayton Christensen has now talked about it as one of the core areas of disruptive or low-end disruptive innovation. Well, that was the business that my grandfather built after learning about how not to do it in Indian Motorcycle. There is a lot of the chip off that block that I took from a personal story. It's important because there's an obligation to be great to your customers, to your stakeholders, your team members, and in today's internet age, all the people who could theoretically contribute from that workforce that's been talked about. So, he loved education. After Indian Motorcycle and Texas Industries, he went on to found the Corporation for Public Broadcasting. PBS, CPB, Sesame Street, this is this man's legacy. Why is that important here and to me? Because at the edges of training this workforce, we're talking about how do you take care of bringing along a world of digital citizens. That's why I started with that phrase, because I believe in it implicitly. And from somebody who comes from my background, just in my life, you'll understand a little bit more of why that transition is meaningful. So as a 13-year-old, my parents moved us onto this boat. I lived a charmed life. I went around the world for 7 years on this boat. And it was an amazing experience to see the world from the sea. And it was also a charmed life because it was something where I was able to experience not only what it meant to go around the world, but also how to live on the ocean and keep a ship going. Clearly, it's not a small boat, but there are bigger. And for me, it was an exposition in systems coming together to see the world. There were many other lessons that were embedded in this that I wasn't aware of until they happened, and that was, shortly after this time, my father went through a major financial reversal and lost everything. So I got to see the world from the sea and see the world from the top, watch a grandfather that had built a lot of businesses, and then figure out how to cut a row for myself to be able to take these learnings and make them happen. So shortly after my graduation from college, which my siblings put me through, I was able to repay that debt by going to China and working for a medical device company. I spent 3 years there manufacturing in Shanghai and Beijing. And it made me learn a lot more about what it takes to do disruptive innovation from the ground floor, building simple things to change people's lives. Diabetes was growing to epidemic proportions at the time in China because of a change in a food culture that was meeting an efficient genotype, and they needed solutions, things that had already been created, but they needed them to come to market quickly and at an efficient price. So that was the first experience for me out of college. A little bit later on, I decided to take a right-hand turn, and it was probably the most important right-hand turn that I've ever taken in my life, and that was to join the Marines. So I became an infantry Marine, and for 9 years, I served the United States in the Marines as an infantry company commander, a scout sniper, and it was an incredible time to learn leadership. And part of feeling the obligation to be great was what was I going to do with that training as I came along. This was my first platoon, shortly before our first deployment on a training mission, and I took those Marines at their word and learned everything I could from them, and everything that I do today is paying back many of the things that I learned during that process and during that time. And so in 2004, in the winter, just before 2005, 2 of my friends were killed on deployment while we were in Iraq together. And one of the messages that I took back from that is things had to change. Things had to change in the vehicle ecosystem, and it was a place where I was going to start this change. So the biggest system of them all is what I went after in building this business. I was truly inspired by Amory Lovins at the time. I had been reading his book about winning the oil endgame, and that was the target that I was going to go after. I wanted to make a change, and I wanted to make it big. One of my friends that was killed was shot exiting a Humvee, and he won a Navy Cross for his actions before he died that day. But if the vehicle had been different, I guarantee he'd still be with us today. And the other friend was my first operations officer who was shot in a helicopter, which landed in one of the few bodies of water inside of Iraq, flipped upside down, and he drowned inside the helicopter. So making our hardware different was an imperative for me. And I'm proud to say that taking on difficult industries is not always the hardest place to do business. But you'll see a little picture from Henry Ford, down, or Frederick Taylor, if you will, down in the bottom left. And then today's factory just before Tesla, if you will. But there isn't that much that's different about these. The die was cast when Frederick Taylor set the scientific method in action. And maybe one of the only other blips is one that Karen brought out just in the slides before about Alfred Sloan and the Toyota Way coming into action. But now the change is upon us. So it's a $2 trillion industry, just the automotive industry itself. Smaller than the energy industry, but definitely one of the biggest. And it's a handmaiden of the energy industry for obvious reasons. 70% of our oil end use in the United States and other developed countries goes into cars and light trucks. 70%. Change the efficiency of our cars and light trucks, and you change the entire energy equation. So it is a direct effect. Furthermore, our loved ones that ride around on vehicles that are unsafe are subject to what will happen if you get hit on this. So safety is imperative. The National Transportation Highway Safety Administration's administrator has gone on record saying that 95% of all accidents in vehicles are human engendered. 95%. So if you find yourself having an argument about how robots will be unsafe on the road, I encourage you to think about the 95% of accidents that are caused by humans that are not robots. It's not enough. We need to make a change. The transition may be painful, and the companies that come in to do it, I would wager, need to have the brightest and best minds working. And I think those rules, much like open source software, are best left to the crowd. Yes, you expose yourself to hacking, but you also expose yourself to the ability to climb a curve that is way faster than Waymo can do it themselves. This is a case where open source software was meant to rule. So for us, building a business off of this imperative got us to the question of, is more the answer? Could we do it more Tesla than Tesla did it? And our thought was no. There needed to be a change in the way that the microfactory could operate in order to be able to uncover trends faster. Autonomy wasn't even a thought in people's mind for vehicles a very short time ago. There was a list of features of of products that would be unlikely to be disrupted by intelligent systems, robotics, and other things like that, and vehicles topped them. Well, we've turned that upside down in a very short period of time. Remember when you thought I'd always drive a gasoline car? Some people still do. So those changes are coming fast, and it's not enough to build vehicles this way. So if you think about it, striving for less was what we really wanted to get to. And this is what I was trying to get to during that time. This is the Mercedes 300 SL Gullwing on the left, a storied vehicle, built pre-war and beautiful example of German engineering. This is the Local Motors Stratty on the right. Nobody knows what it is. It's not the storied Mercedes 300 SL Gullwing, but what makes it special and different is it only had 50 parts. And we printed it in 40 hours. We hit go, and it came out the other end, and then we drove it away. That's a way to change manufacturing because there was no tooling cost at all. You've heard people talk about that maybe this will be possible. Come take a ride with us, and you'll see it in real Technicolor. And what started at 44 hours now takes us much shorter. So our exploration in vehicles started with this vehicle. We heard about it a little bit ago, the Rally Fighter. We couldn't 3D print a car when we started with the Rally Fighter. So we started with digital methods that were the best that were around. Shortly after that, we went on to a motorcycle where we were able to 3D print the intake. And this was designed in our community also, and we printed that whole intake minus the 6 screws that went in the front. We printed the cover, we printed all of it, and we did this computational fluid dynamics to optimize the airflow in that intake. Pretty simple exercise, but there were some other cool features about it. When you ride a motorcycle, your knee could fit right where the scoop came down, and we moved that around and printed it again. But it showed the potential of what you could do. But we couldn't conceive at the time of printing a frame or printing a fuel tank or other items like that. Fast forward to just 2 years after that, we began to uncover some of the materials that allow us to be able to print a vehicle much like the one you saw in the video before. And this was the world's first 3D printed car. Another Guinness Book of World Record entry, the Strati, designed by a community member who's Italian and joined us at the unveiling, or the unprinting, so to speak, of the first vehicle. And he said to me when we were driving away in the car, he said, only the country that could put a man on the moon could invite an Italian that knows nothing about vehicle creation to be able to design the world's first 3D printed car. Something about that was just magical. So, co-creation and micro-manufacturing at its best. Shortly after, we followed on, and this community member, Kevin Lowe, is an employee at Hewlett-Packard. He doesn't work for Local Motors, for sure, and he works for what you could think of as a totally different company that's involved in 3D printing. But Hewlett-Packard was super excited to see that he rose to the top of this challenge to design the first highway-capable 3D printed car. Carried 4 people, goes about 110 miles an hour, and it was a first try to bring what you saw in the Strati forward to the next evolution. The opportunity to take a vehicle and really reimagine the powertrain, that red unit, and the batteries, and all of the things that come into a feature to make it different shape, number of people, way in which you configure it, and get tooling costs totally out of it, is the promise of what this technology has allowed us to think about. And it allows you to really make a digital community come together. So, what is this boring slide of blocks that has that 7-year number underneath it? This is the launch cycle of a vehicle, traditionally. And it goes all the way from raw materials on the left, all the way over to customers on the right. And it's missing the all-important recyclability loop or end-of-life loop that happens far down the road. But this is the originating life cycle of a vehicle. For us, getting rid of logistics and dealers was an incredibly important piece of this. And really, when I say getting rid of them, I mean mashing them up with the microfactory. And then being able to bring suppliers in line with that microfactory so that you could shrink PDP down to 6 months. That's what digital can offer you. Remember, faster, less capital because of more minds? This is that explained in a visual squunch, a little slinky put together. And it happens out of our microfactory. This microfactory, if we're going around from the integrated microfactory experience, counterclockwise through the light lab, into 3D printing and assembly, is the box you saw on the hill in Tennessee in that picture that I showed you. It's a real type of building and a real building. And the one we have in Berlin is the same. And it's capable of receiving instructions to make these vehicles and kicking them out the door for customers to buy. And it's not focused on business to consumer or business to business alone. It's B to A. It's business to all. We don't intend to be put in a box. When you go for economy of scope, you need to be nimble. So, we can serve both types of consumers and governments, B2G. So if you think about this, our latest vehicle is a logical extension of where we've come from. The industry is going electric, the industry is going autonomous, and the platform of technologies really needs to be wide open to be able to add things. So we did a challenge for urban speed vehicles, and Ollie was the result of that challenge. Ollie was designed by a community member, Edgar Sarmiento from Colombia. And Edgar not only won a prize for this, but he will receive a royalty for every Ollie that we deliver. And we will deliver 25 of these this year. 25 of them. And this vehicle, if you made it in a component style, would look like what you have on the left. And since we're in the Exponential Manufacturing Conference, what a luxury to be able to talk about some of these differences. Component, right here. Direct digital, right there. Put them next to each other, and you begin to see some of the differences. What are the differences? Making this as a component vehicle is 1,600 pounds. We can save some weight at 1,500 pounds, but the assumption that this is a weight saver from the beginning is probably incorrect. That's a later effect of being able to do things in a direct digital process. Some things that have been glided over in the first couple of days, or the presentations that we've talked about, is how long it's going to take to be able to make anything you want in any geometry at this size. There are still real blockers to being able to put that in your hands and allow you to drive it away. But today, the best we know is we'll shoot to keep the weight the same. However, this is really awesome. 60 times part reduction and hour reduction for us to be able to build a vehicle. 60 times. It's incredible how fast you can do something without doing it the way we have always done it before as a component vehicle. All of the little fasteners, all of the glues, all of the things that we want a robot to repeat in the traditional ethics of what we're doing are changed when you redesign from the bottom up. Transforming a product or a brand means that you can't do it the same way you've always done it. This was an unintended consequence. And if your mind jumps immediately to what this does to the workforce, I'll take those questions maybe off stage, but what I would tell you is the number of young Marines that don't have college degrees that are learning this system and learn to be able to make vehicles this way without a college degree, to me, is an awesome redoubt to the fact that this job of being able to put a fastener in a vehicle is going away in the future. It's a change for sure, but it is definitely a change for the better in my mind. Unit cost. 5 times reduction in the cost of making this vehicle for materials and parts. 5 times reduction. So when you look at it, I think you can see why we need to develop it. But it requires certain things like a new set of tools. The ability to be able to do digital manufacturing is not just about printing, but it's also about subtractive and assembly. And you need new tools, new software tools, new hardware tools, and there is a whole host of vendors that are here and in the rest of the world that are working on providing these tools, and we need them badly. And if we have to, we'll make them ourselves. We'd prefer not to. It would be better for us if we could have that ecosystem come along as fast as possible. But there's a new way to analyze today. And there are companies out there right now working on these. But we need the material science to come along and give those precepts to be able to make the analysis tools more predictive and better. But the disruptive result is a 3D printed Ollie. So what you see and I just showed you and we will deliver is a fully 3D printed solution.
Hello, my name is Ollie, and I'm making history.
This is a huge day in automotive history. Not only is it the day where Ford Motor Company was incorporated June 16th, 1903, but also it's the day where we got people comfortable with the idea of riding around in a completely self-driving vehicle. I'm Jay Rogers, and I'm the CEO and co-founder of Local Motors.
I am the first cognitively enabled vehicle. I seat 12 passengers. And you can ask me anything.
Ollie, why don't you say hello?
Hi everyone, my name is Ollie. I'm a self-driving vehicle powered by IBM Watson technology. I can help people get around National Harbor.
Ollie, I'm hungry. Where can I get some food?
National Harbor has some great seafood. Would you like that?
That sounds great. What's good?
Well then, try the Crab Cake Cafe.
All right, I'll go there for dinner.
Okay, but don't forget your umbrella. There is a severe thunderstorm warning tonight.
The sensor set on this vehicle allows us to be able to feed data to Watson and feed data back to Ollie to make life more enjoyable. Thanks, Ollie.
By the way, I like your bow tie. I'm what's next in automotive innovation.
That's incredible. And to see that come about in just under a year, being designed by a community, is the promise of what's to come. And so what will be next as a result, if that doesn't change your mind about what co-creation and micromanufacturing can do, maybe some of the other little teasers of what we're doing on the edge can help. Local Motors is focused on ground mobility. What we've built with GE first, starting with First Build, as Karen mentioned, and if you were in the design workshops with Diane Finkhausen, was the ability to be able to speed the production of GE Appliances business by 24 times using co-creation and micromanufacturing. We replicated an entire ecosystem on those same 2 precepts to change GE Appliances' product development process. And then we're doing it again for Fuse. So working together with our partners at GE to start with inspection technologies and then moving that capability to engage Fuse for other areas around General Electric's business can be one of the parts that allows brilliant factories to be able to come to the fore on that blue edge before you take it to the mass. Additionally, in the air, some intrepid people, one of which is in the room here today, saw this potential at Airbus and said, we got to make this happen for aviation. It's one of the ways where we can spend less and do more and change people and change their lives. So engaging with Airbus to be able to create co-creation and micro-manufacturing is one of those journeys we started on 18 months ago, and moving that through now to what will be the creation of a first microfactory for Airbus is the result of it. And we designed and built this cargo drone, both 3D printed and in traditional materials, and flew it in a 27-day exercise from design to creation as a lifter, pusher cargo drone capable of carrying 5 kilograms, 100 kilometers to fit a mission profile. Co-creation and micro-manufacturing can affect appliances, inspection technologies, aviation equipment, and ground mobility. So, what's next? I'm announcing that we've partnered with Hewlett-Packard in order to be able to focus on what happens when SpaceX or Blue Origin gets us to Mars. How will we have an ecosystem there to be able to support us? So the Project Mars initiative that we're embarking in with Hewlett-Packard allows us to be able to focus on food and farming. It allows us to be able to focus on habitats, transportation, water systems. These are the things that will allow us to be able to change the world as we know it. I want to thank you for your time today, and we have 3 minutes left, and I'd love to be able to take 1 or 2 questions so that we can maybe expand the discussion beyond just what I wanted to say. So, over to you.
The biggest roadblocks to it becoming a mass manufacturing vehicle?
What are the biggest roadblocks to becoming a mass manufacturing paradigm? Our goal is not to be a mass manufacturing paradigm. Our goal is to be able to build the products that people want and transition them to mass when it's necessary. The goal of a microfactory is not to become a mega factory. The goal is to be efficient, to be able to make money at low volume and discover the wins and then pass them off to factories that are capable of scaling them. Do we print or produce the engines ourselves? No. When we were looking at how to print the vehicle, one of the first things we wanted to do is change the construction to make it more flexible. And so the opportunity for us to be able to focus on that was the first thing we went after. Now, what you look at is what can you do as you look down the road. Axial motors were all there were at the time that we were starting. But the first hub motors will go onto our vehicles this next year, which means changing them to get them outside of the center of the vehicle. And then beyond that, there are certainly people working on printed high cohesivity materials that will allow us to be able to think about reusing rare earths, and those are exciting possibilities that remain in the future. So certainly printing of motors is something which will lend itself well to future technology that is in the offing right now in labs, but not ready for production yet. But it's just that type of technology that we want to bring online. Yes, sir.
What a phenomenal story. Can I shake your hand, please?
Oh my gosh, sure. How about I'll come on down and shake your hand? Thank you very much. Thank you. Thank you. Well, I mean, maybe one more question? Yes.
Can you tell us some more about the water cleaning project?
Sure. So what we're looking at when we look at those 4 systems on Mars is trying to get people's ideas around how to solve these problems. Pre-positioning, if you've done anything in flight before, whether it's exo-atmospheric or endo-atmospheric, you'll know that weight and size are serious considerations. And then also if we're going to be populating other planets, getting down to the simple things of farming and water and other items like that are important. So as we approach that project, what we'll do is we will break it down to component parts and talk about how do you create water on Mars. So if you're looking at what's there, how do you get it to a system where you can bring it into clean drinking water or water that's available for farming or any other necessities that we have to be able to do it. And that will be the subject of the challenge. So maybe the best way to think about it is we will employ a scoped project with subject matter experts and go after the challenges for developing water, habitation, transportation, and terraforming on Mars. So more to follow on the project.